My name's Taylor. I'm from Utah State University, and what I'm going to talk about today is sort of a new way that I've been thinking about things and kind of trying to use data pipeline as a thought framework for our research process as a whole in educational research. The opportunity was kind of where I was going to start, but you guys have covered that beautifully, so all I have to do is say, hey, yay, we have a great opportunity here. So the idea here is to really get at how data visualization can help us at every phase of the pipeline. So we often think about how it helps us, particularly in presenting data and in analyzing, either in our final analysis or an exploratory analysis, as we've heard a lot about. But I want to think about some of the ways it can help us really throughout our whole pipeline, and even pipeline visualizations can help us organizing our process and our teams. This sounds a lot like just to talk about data management, so I do want to take a step back and really say I do think of this as a thought framework, and hopefully that'll be conveyed, and you guys will have some great questions that help with that. So what is this data pipeline anyway? Well, basically, we all start with stuff from other databases, stuff from the web, sensor data, clickstream data. Hey, we even start with a lot of things that are on paper still, sadly. I'm trying to make sure that stops, but you can't have everything. So, and we start with that, and it goes into that pipe. And what do we get out of it? Well, we go do some machine learning on it. We put it in databases. Some people still put it in OLAP cubes. And then we have this kind of intermediate visualizations that might be used internally. They might be used for a presentation like this. They might go in a paper, right? And then we have the kind of very public finished presentations, or visualizations, which are like dashboards, right? So I want to kind of step back and think about where it can help us along the way. What's a data pipeline again? It could be, it's not going to be anything fancy. This is Taylor drawn really badly on the board, like usual. It could be, kind of a more typical business type pipeline. It could be a big data pipeline. So this is the Amazon Web Services definition of their pipeline, right? For our group, we've kind of begun to, and I mean my research lab, we've kind of begun to look at it as a piece like this. And we go back and forth about, does this have too many nouns? Is it process enough? And all that good stuff. But anyway, so we kind of start with our raw data. We're going to clean and parse. We're going to end up with what we call roughed data. And then come into another phase of analysis where we're doing some exploratory, some manual analysis, and then kind of try to create automated analysis tools. And that's what gets us to kind of final presentations or the dashboard type of phase. So I'm going to go through this, kind of break it out in pieces. So at stage one, what are we doing? We get lovely raw data, like, trying to get some XML files, talk to some JSON files, and get all that into a database, and fun. So how is it possible that visualization can help us here? Well, there's actually coming to be quite a few tools that, this is OpenRefine, which used to be Google Refine, but you can, so you get that database, and you've got free and reduced lunch, somebody mentioned yesterday. And in one place, it's in initials. Another place, it's spelled wrong. In 47 other places, it's somebody's category that's a 1, 2, or 3, and you don't know what the 1, 2, or 3 is, and et cetera, et cetera. You've all been there. So what this tool visualization doing is helping us is showing us as we're reducing, it clusters basically all the names, and it shows us as we're reducing those clusters. So we want to get down to the names that we want, or at least one version of it. But we can use this kind of visualization tool to help us in that cleaning process. This one, everybody's going to be familiar with, right? And so simple ERD, but an entity relationship diagram can help us start to figure out and refine and define the structure of our data. And we might even, sometimes in this process, we find out we don't want a relational structure for this one, right? We don't need that. But this visualization helps my team work through those issues and figure it out. And figure out what's in our database. It also really makes another key point here for visualization, I think, in education research, is we have very varied teams. So I do STEM education research. I have plenty of people in my lab who have never taken anything more than basic stats. And yet they need to know, this can help them understand what's even in that database. What might I be interested in, as opposed to thinking about this database, oh my God, right? So that really gives visibility for me as a manager, but also for folks in the lab of all different kinds of expertise. And I'll come back to that point a few other times. So this is just a picture of essentially a Git repository, GitHub, etc. And what this does for us in visualization is be able to, we can see all the changes that were made to our code, our Python code, da-da-da-da-da. It was all committed, it was all pushed up. And over here we can see where these streams are connected, right? Where things fork, where things become connected. Again, giving visibility, but also helping team members understand what happened with that code. And yeah, I'll just say revision control, revision control, revision control, and the more that we can see that visually, the more it's going to help us. So that's kind of some of the things we have here. What are some of the challenges for our field as it's growing in this area right now? Capacity, capacity, capacity. Particularly for real big data, right? So a lot of what we are working with, I would say right now, in learning analytics / educational data mining, and this might not be true so much if we get into the world of ed tech startups because a lot of them already have real big data, but really in the academic side of it, and I'm not trying to contain this only to that, but discussing some of these challenges, I am talking about more of us, those of us trying to build programs and things like that in learning analytics. So we really have a capacity issue, particularly at this level. Another issue for us is, and this is probably true in business as well, but our teams change very quickly. I have a kid who comes in as a master's student, they learn all of this stuff, and then they go get a 6-figure job and they're gone. So yeah, kind of how it works. But disparate data sources and shapes, I think we all understand this one pretty well, accessing it through a variety of protocols. And just the nature of data, it's changing, right? Tabular and relational data, they're still out there, but things are changing quickly. So another challenge really is keeping the pipeline as your guiding framework. So it's really easy to, and I can't tell you how many times my data scientist and I have this conversation, I'm like, I don't need the perfect database. I need the database that's going to get us to the next stage, to get us to the next stage, to get us, and we're going to refine. Don't worry, we're going to come back to it. It's okay. We're going to come back and fix it. And I do let him go back and fix it, so I'm not just lying. So there are a lot of really new and developing tools to help at this point in our process. Open Refine, like I showed you. Trifacta, which used to be, I think it was Stanford's Data Wrangler. Data Tamer is one out of MIT. Hunk is from the company Splunk. It's for big data. IPython with Panda is another example. And the capacity building efforts in the field are happening. I would say at this level, and those of you in the room who, like me, are in the process of working with groups to develop master's programs, this is kind of maybe where we're having to think a little harder because we have a little bit less capacity right now in the field in this area. So, but we are starting, and we'll get there. Okay, going on to stage 2. This is going to be a little bit more familiar, probably, or at least more common. So, example tasks: finding, defining, and refining what our variables of interest are, whether they're predicted ones that we went in looking for because we're trying to test theory, or whether they're emergent ones that we end up finding. And of course, visualization of preliminary results. And for that, someone brought up yesterday, I think a couple people did, kind of the internal versus the external visualization. So these are very internal, team-using visualizations, right? So a lot of work I'm going to be talking about in here is based on this game, which is called Refraction, and I am sorry to all the physicists in the room because it has nothing to do with refraction. It just has the word fraction in the name. So you basically, kids make fractions by doing repeated splits. This is a theory of fraction learning that folks seem to like right now and seems to be pretty effective. So for instance, to try to make that 1/8, you need to make a half of a half of a half by using splitters. There's 1/2 and 1/3 splitters on there. You can bend things around. Happy animals show up when you get the shape right, when you get the fraction right. Yay. Okay. So the level that any visualization really I'm going to show you today is one where kids had to make a 1/6 and a 1/9 fractions using 1/2 and 1/3 splitters. So the first thing we kind of had to say to ourselves was, well, what do we care about in here? I have all the clickstream data from everything they did. Do I care about every time they use one of those little benders to move a thing around a rock? Well, I might eventually, but right now what I care about, because I'm trying to test this theory of, splitting, is what is a mathematical state in this game. So visualization really helped us with this. These are really basic, but it helped us to be able to see how things change, to say, okay, well, here's a state. This is the whole laser, regardless of where it's pointed, regardless of all that other information, with a 1/3 splitter on it, right? There's a 1/2, there's a 1/3 with a 1/2 and a 1/3 on 2 of the little thirds, right? So next, then we could say, okay, well, how do we What things do we care about as kids move through a level? And so, again, this is an internal, really cruddy visualization, right? But it really helped us be able to see, okay, look at this. They're repeating all over the place. So this repeating action is going to be really important in understanding what kids are doing. And in this one, all they're doing is going back and forth in between the 1/2 and the 1/3 state, right? So in comparing that to a post-level visualization, right, now they're, and pre and post, by the way, is they did this level before they did other levels, and then they did it, we kind of use it as a pre and post test. They did it after they did a whole bunch of other levels. So here you see a lot less repeating, a lot more complex states. So then we said, wow, okay, complex states are going to be really important. What's a measure of complexity of these states? So it just helped us define our variables that we were looking for. We also started iterating on those variables, and on the visualizations, when we did that, we discovered another thing, which was that the space of the game, we kind of divided into two places where what we call them the 1/2 space and the 1/3 space. But essentially what it's about is whether the kid starts by putting a 1/2 laser on and makes things based on that, or they start by putting a 1/3 on. The reason it matters is because you can't make a 9th without starting with a 3rd, right? Obvious. But that helped us understand that that was going to be a really important variable, and it has ended up in a lot of our analysis being important. So moving on, I'm just going to, because these are kind of the same, I'm going to go through them and then talk about some challenges. So moving on to, so we've done some preliminary and all this, and this is the space I'm going to try to go a little quickly over because I think we're pretty familiar with it and we've seen a lot of things. But, you know, what are we doing with these things? Theory building. All right, we've got this theory of splitting. Hey, look, splitting does matter. Can we find some results that show that? So these are kind of a within preliminary association rule mining analysis. And we just looked at and said, which states in the pre-level at all are associated with winning? It's kind of back to the, you know, market basket. If you buy diapers and beer, what else do you buy, right? Everybody's favorite example. And so this is the successful state right here. It's not part of the rule, but just to show you what it looks like. And so we found that on the pre-level, basically, as long as they were playing with thirds at all, there were like tons of these rules that came up to really high confidence. As long as they were messing around with thirds at all, that was good. On the post level, what was really interesting is it really mattered just if they made a 9th ever. Like, it didn't matter if they got it, you know, if it was not hitting the correct target or anything else, but if they were messing around with 9ths, then that was helpful. So this is kind of showing that, you know, they're developing splitting and that splitting is a helpful practice. So we can do it for theory building. These I'm going to go through, and I'm not going to explain it all. I'm just saying, for presenting neuroscience results at AERA, you know, this was a NIRS study. We like NIRS because it means that we don't have to put kids in machines and they can actually move their hands, so it's, you know, really helpful for neuro studies. But, you know, you're trying to present this stuff to an audience that's not a typical audience. So having some nice visualizations that meet all the great criteria that you guys have all been talking about the last couple of days was very helpful. A big one for us is representing change over time and being able to understand what's going on in our data as they change over time. So we look a lot at students programming in online visual, or well, some of them are online, some of them are offline, visual programming environments, but we have all the clickstream data. So again, we have every little code block that they put in. How am I going to make sense out of all that mess? So one of the visualizations we have is looking at similarity in Novices programs. This is over a 90-minute programming period. What else can I tell you about it? It's Jacquard distance, but you could do it a bunch of different ways. So here's what it looks like. Closer is more similar. They're on teams, they're all in the same room, right? So we get very quickly, hey, they're pretty similar. Now, and compare that to similarity in relative experts. These are all high school students, but these guys have done a year of robotics and the programming that goes along with it. So when we look at theirs, they're all over the place, right? We find out all kinds of things. But so what's the point of this other than being kind of cool looking? When we look at this, then we can say, okay, cool. Then it's going to actually be worth our time to go compare and do some clustering on these sequences of program states, similar to the mathematical states we defined earlier, which is not particularly computationally expensive, but it's if you really don't think there's going to be anything there, it's not worth your time. So it is, more complex than a lot of the analyses we do. So it's really nice to know ahead of time whether that's going to be useful. So next, I'm going to talk about this stuff in terms of deciding what to automate. So we've been talking about dashboards. We've been talking about lots of things. A lot of what we do relies on automated back-end analysis, right? And when we get into a new environment, and we're doing this with Scratch right now, we have to figure out what it is that we even want to have that critter spit out at the end of it. What do we want to show up on that dashboard, right? So with Scratch, here's a little Scratch program. And, we've got this nice little guy. He jumps up and down. Scratch is being weird today, so it's not behaving too well. But anyway, he does these things, and in order to run him, there is a fairly complicated program over here, represented in a visual environment, because that's what kids do to program in Scratch, put these little blocks together. And these are the critters that you create in Scratch called sprites to attach, to make them do things with scripts. So we look at that from an analysis perspective, and what do I do with this? I've just got all these blocks, and when you pull it out of Scratch, you've just got a bunch of blocks and not how they're related to each other. How do I start to define computational thinking concepts? Okay, loops might be pretty easy, but it's pretty hard problem from this setup. So then the next thing that we did is kind of say, okay, well, let's look at some things about how this changes over time. And I'm just going to start running this video as I explain it to you, because it's, again, internal learning visualization. It's a lot of fun, but it's kind of a mess. You'll see it, though, after a minute. Let's see. Do we have enough of it on screen? Yeah. So up this way is adding sprites. You can imagine that's not too surprising. The kids start by adding lots of things on their board, right? Out this way is scripts, and the more complicated and the more intricate scripts and the more connections there are between them, you see more lines between stuff and more of those little dots. I will just say everybody in the room is thinking, but more complex programming isn't just good. And yeah, we know that. But this is just a way for us to start visualizing. So what you'll start to see as you watch, and it's going over different kids, right? You just start a new kid. What we started to see was, all right, so they're doing sprites, adding sprites, and then a lot of them start coming out this way some, but there's this one bump that you'll keep seeing over and over again. Well, maybe not with this one. I didn't figure out how to time this part perfectly, but it doesn't always work out. There you go. That's octopus dodge. So what that is, and we all knew that the first second we saw it. What that is the beginning of remixing. So up to there's kids are programming for 10 days. This is all of their saves over all 10 days, which is about 13,000 saves altogether, which a save is the code snapshot of their program at that point. So octopus dodge is when you start, up to them they've been doing things on their own from scratch. And then they get a program to remix. And this is a really typical practice that kids do when they're learning to program, and we know from kids just working on their own on the Scratch site, they do it all the time. They go get other kids' projects and remix, and it's a great way to learn a lot more complicated concepts. And it's also, I think, a great practice to encourage, because we know that real programmers, grown-up programmers, do this all the time. You don't start writing it from scratch if you can avoid it, right? If it's already been written, you go get it. If I go get all my R code that I can and then adapt it for when I need to. So anyway, that kind of showed us some of the things that we wanted to go look for and build into our automated tool. There we go. We call it the fun tool. Don't ask why. Other than it is a lot of fun to make. But so here again, now visualization is helping us figure out what on earth we even mean by an automated tool to parse Scratch programs, right? So right now, the beginning part is actually we are using Scratch 1.4 and literally saving. That's why we have these silly little disks on here. Saving the things out of Scratch 1.4, pulling it into our servers, kicking it up to our central servers, and then automated using Hurt Python tool to automatedly parse these critters into JSON files that we can actually do something with, as opposed to just all those pretty blocks. That goes into, of course, our databases, yada yada, do manual analysis, beginning reporting. And so what we're in the process of now is actually, in Python, building that automated analysis tool. Well, what does this have to do with visualization? Well, trying to explain this to my whole team was, it's funny, while we wrote the grant, it took me a while to realize that my whole team didn't necessarily actually understand what we were doing. Because it was like, oh, we're just doing some analyses, and here, great, we've got all these great No. We're building a thing that does those analyses for us. So this visualization, and this is a really early version, and we're still iterating on it, and a lot of times we just draw it on the board, right? But this visualization is really helping people come to a place where we're in shared understanding of what we're even trying to do. All right, so I'm going to go over some of the challenges and stuff basically over stage 2 and stage 3A. And they're pretty much the same right now for our field. And I say our field, but if you read big data, you go to Strata, you know that everybody is kind of scrounging for looking for people who really have that first stage experience really strongly. And even in these stages, my master's students are graduating and going and getting 6-figure jobs. So there are some new and developing tools that really help us in a lot of pieces in this stage, and I couldn't even begin to go into all of them. But RStudio is one of them. RStudio is great because I've been using R for years, but as we brought up yesterday, convincing your team to use it can be an interesting issue. RStudio is a nice visual interface for R. There's others out there, Revolution Analytics, etc. And it really got, so my team now, they're all people who do nothing more complicated than a Novas, running means, whatever. They're all like, I don't want SPSS anymore. I want R. I'm like, yes. RapidMiner, Weka. MySQL Workbench, again, like RStudio, it has a lovely visual interface, helping members of the team understand, well, first of all, just helping everybody get on the same page of what do we even have, what's in that database, how should it be organized, blah, blah, blah. People can have meaningful conversations about it, but again, for members of the team who are not the data crew, they still can go in and write a simple query and get the data they want and go run their basic analysis and yay, happy. So. And capacity building efforts in learning analytics in this area are pretty far along and definitely strongly underway. I don't know if George is here, but yeah, so George Siemens and I and a lot of other folks met last weekend or weekend before at CMU to try to put together a course repository. This is the Learning Analytics online master's program, essentially. Course repository of all the courses we've developed, and then trying to get people involved. So if you're interested in being involved, please let us know. There's already master's programs at CMU. I think Teachers College is approved. I'm not sure. If not, it'll be soon. And then of course, folks here are developing one. Stanford's developing it. We're developing at USU. It's it's on the way. There's events for more of those of us who are already in the field. Learning Analytics Summer Institute started last year, happening again this year. Hopefully we'll continue. We come together for a week. It's kind of like the beginning of cognitive neuroscience. We all, whoever knows what about what, trains other people about stuff and share results. And it's really not meant to be a conference. It's more of a learning experience. And then there's the Learning Analytics and Knowledge Conference, Educational Data Mining Conference. There's Learn Lab at CMU. So there's a lot going on to develop capacity in this space. So, last little stage, and I'm not going to say a lot about this one, is we've got the automated piece, or, where are we going to do the presentations? Yes, I'm talking about dashboards, but I don't have a good dashboard picture because I'm not that, I don't need to say anything more about that. So, the last part about using visualization I wanted to say was just, this is our process that we do. We use this to guide each piece. And again, it really, as I talked about earlier, means that we understand that it's iterative, that we're going to get from raw data to some rough data, not super quick, but as quickly as we can, and we're going to keep building on that and keep coming back to the different pieces. Again, this is on the wall in the lab. It's just a representation for everybody, and we're iterating even on that representation. So, challenges here. Teachers are overwhelmed with the 8 billion kinds of visualizations we're providing them. I don't know that means teachers are having a problem. I'm not so sure about that. I think maybe we need to figure out how to represent data better to them, but anyway. And there really aren't, even though I said there's a lot of great tools at other levels of this, there really aren't a lot of great tools for actually creating and visualizing and maintaining your pipeline, particularly ones that are linked to things like your analysis tools and linked to your Git repository and linked to, so that process is very visible and it doesn't take a lot of extra overhead to maintain. Managing teams always. I don't have a lot of options for this right now, but so I figured we've got a couple minutes left, so I would leave it for your ideas and questions. Thank you.